In part 3 of our Windows Server 2012 R2 class, we want to connect this virtual machine to a network. So you see here that this machine has no network connection, and we go to right click to the start button and say network connections. Here is no network cable plugged. So we go to File, Settings, and we go to the network adapter, and this what you see here is the network adapter, but there is no virtual cable plugged in. So we want to connect this to the Wi-Fi switch, and we click OK here. So now we make an IP config in the virtual machine, and we see here that we are in this network here, and here on the host machine we have the same network interface here. Every machine, the virtual instance and the host computer, gets its data via its network configuration over DHCP. We could reach Google here, for example, and we should also reach Google from the virtual machine here. So you see that every machine is in the bridged networking mode. Bridged means that the host computer has or provides a virtual switch for every of the VMs, and every machine is in the same network. There is no network difference between the host computer or the virtual machines for other external devices like smartphones, client machines, or what else. A client can't figure out if this is a virtual machine or a host machine on the network layer. But you see one thing here, we are in a corporate Wi-Fi environment, and there are some DHCP and MAC issues and security protections. For this reason, we have to change from the bridged mode to NAT. NAT means Network Address Translation, and works as a router on the host machine here, and we have then something like a router on this physical machine here that separates the VMs into a other network. This has nothing to do with Hyper-V and is not a feature provided by Hyper-V. It's a feature provided by the Windows operating system itself. Therefore, we go to the network connections here, and now we will create a new virtual switch here, but we call this internal. Here we say Wi-Fi internal, say internal network here, and say apply. Now we have a new network connection here that is called virtual Wi-Fi internal. This is the Wi-Fi external. But now we will go to the virtual switch manager and delete this Wi-Fi external switch here and say yes. Okay, it cannot delete it because it's being used now, so we disconnect this VM from any networks, and now we want to delete it. So now we have only a Wi-Fi internal network here. We could also name this a bit more like this, say apply, and now we go to the physical Wi-Fi connection here and right click properties, say sharing, and now we allow other network users to connect through the computer's internet connection. And here we select the Wi-Fi internal. Allow other users to control. I don't think we need this. If we need this, we could allow it later. Say OK. And call this virtual Wi-Fi internal too. And now we look at the network here. What we have here? We have here a separate network with 192. And what do we have here? 100. Okay, this is the same network. And I think we should have only one internal here. The switch extensions we could disable because we don't need this really. Now I refreshed this page here and we only have one virtual Wi-Fi internal. So what happened now? This is our physical Wi-Fi card built into my notebook. This Wi-Fi card is connected to this Wi-Fi here with this network settings here from 10 point etc etc. So we have full connectivity to the internet here. If we make something like traceroute, we see how the packets get routed to Google. We let this do what it wants to do, and now we go to the virtual machine and connect this machine to the so created Wi-Fi internal. Say apply, okay, double click, and now this should, we say yes, and now this machine should also can connect to Google. In the meantime, I changed the DPI settings here a bit, that the font is a bit bigger here, and now we make ipconfig here, and we see that this VM is in another separate network provided by the host machine. And we'll also make a traceroute here to Google and compare this one here. So you see that here it goes out to A1, which is the major provider here in Austria, to this Google server. What we here see now, after the traceroute has finished, the host machine here on the right side goes to the proxy server here in my Wi-Fi and outside to Google. The packet here goes to the Hyper-V server.amazhome.net. This is the router, the virtual router here in this network card here, and then goes to the proxy server here in the firewall and outside to Google. You see here you have 15 steps and here you have 13 steps. So why do we need this additional NAT routing here? Because many corporate Wi-Fi's or WLANs do not allow bridged networks on virtual machines because they have a very restrictive port security and so-called MAC spoofing and other security stuff where they don't allow virtual instances and a network within these virtual instances. So now the Wi-Fi thinks that everything goes over this virtual router here, over the Hyper-V server, over mine Hyper-V server, and you don't have to worry about Wi-Fi security settings. You should know that this is only used in corporate networks, so if you do this at home, you don't have to do these additional steps to use NAT on Hyper-V. If you are at home, you only create the external switch and connect it to your Wi-Fi or to your physical Ethernet connection. What we could test now is to ping the Hyper-V server and to ping this machine here. Okay, this won't work because the firewall here is still turned off now. We only use this NAT configuration for this demo environment here because we don't want to get any network issues. Now this was the networking connection for the first VM. Thanks for watching and see you in the next videos.